Why does anything exist at all instead of nothing? This is one of the deepest questions we can ask, maybe the deepest. It's not a question about what the universe is made of, or how it evolved, or where it's going. It's a question about why there's a universe in the first place, why existence rather than non-existence, why something rather than nothing. For most of human history, this question belonged to philosophy and religion. It was beyond the reach of science, beyond the reach of physics. But in the last century, our understanding of the universe has changed dramatically. We've learned things about the nature of space, time, matter, and energy that our ancestors couldn't have imagined. And these discoveries have given us new ways to think about the question, new perspectives, new insights. After 50 years of working with quantum mechanics, cosmology, and the fundamental laws of physics, I can tell you this. The question of why the universe exists is not as simple as it seems. And the answer, if there is one, is not what most people expect. Let me explain. Before I get into the physics, I need to explain why this question is so compelling, why humans are so drawn to it, why it feels so fundamental. The question arises from a basic observation. Things exist. You exist. I exist. The Earth exists. The Sun exists. The galaxy exists. The universe exists. This is undeniable. We experience existence directly. We are existence. We are part of the universe, made of the same stuff, subject to the same laws. But existence is not self-explanatory. We can imagine a state where nothing exists, where there's no matter, no energy, no space, no time, no laws, no universe, just nothing, absolute nothingness. This seems like a simpler state, a more basic state, the default. If nothing needs to exist, why does anything exist? What caused existence to happen? What brought the universe into being? This is the question, and it's deeply unsettling because it suggests that existence is contingent, that it didn't have to be this way, that there could have been nothing, and yet here we are. Philosophers have grappled with this for millennia. They've called it the fundamental question of metaphysics. Why is there something rather than nothing? And they've proposed many answers. God created the universe is necessary. Existence is self-caused. Existence is an illusion. But these are philosophical answers, not scientific answers. And I'm a physicist, so I'm going to approach this question from the perspective of physics, from what we actually know about the universe, about space, time, matter, energy, and the laws that govern them. And what physics tells us is surprising. It tells us that the question itself might be based on a misunderstanding, that the concept of nothing is not as simple as we think, that nothingness might not even be possible, and that existence might not be contingent. It might be necessary, or at least inevitable. Let me start by explaining what people usually mean when they think about nothing, because the intuitive concept of nothingness is central to the question. When we imagine nothing, we imagine the absence of everything. No objects, no particles, no matter, no energy, no light, no space, no time, just emptiness, void, the ultimate absence. We think of nothing as the simplest possible state, the state that requires no explanation, the default. If nothing exists, there's nothing to explain. But if something exists, there's something to explain. Why this something? Why not nothing? This intuition is so strong that it shapes how we think about the universe. We assume that nothing is the natural state, and that the existence of something is the puzzle, the anomaly, the thing that needs explaining. But this intuition is based on everyday experience. We see objects come into existence, a chair is built, a house is constructed, A baby is born, and we see objects cease to exist. A chair breaks, a house collapses, a person dies. So we think of existence as something that happens, something that begins and ends. And we imagine that before anything existed, there was nothing. But this is not what physics tells us. Physics tells us that nothing, in the sense we intuitively understand it, might not be a coherent concept, that the absence of everything might not be possible, that even empty space is not truly empty, that the laws of physics themselves are a form of something, not nothing. And this changes the question. If nothing is not possible, then asking why there's something rather than nothing is like asking why circles are round. The question is based on a false premise. Circles are round by definition, and existence might be inevitable by the nature of reality. Now, let me explain what physics tells us about empty space, because this is the first step in understanding why nothing might not exist. In classical physics, empty space is simple. It's the absence of matter, the absence of particles, the vacuum. You remove all the atoms, all the molecules, all the particles, and you're left with empty space. Nothing. But in quantum physics, this picture is wrong. Empty space is not empty. It's filled with fields, quantum fields. And these fields are not nothing. They're something. They're real physical entities with properties, with dynamics, with energy. A quantum field is a mathematical object that exists at every point in space. It has a value at every location, and this value can change. It can oscillate. It can fluctuate. The field is always there. Even when there are no particles, even when space appears empty, particles in quantum field theory are excitations of the fields. They're not little balls of matter. They're ripples in the underlying fields. An electron is an excitation of the electron field. A photon is an excitation of the electromagnetic field. A quark is an excitation of the quark field. And the fields exist everywhere, always, whether or not there are particles, whether or not there are excitations. The fields are the fundamental reality. The particles are secondary, temporary, conditional. So when we talk about empty space, about the vacuum, we're not talking about nothing. We're talking about space filled with quantum fields in their lowest energy state, no excitations, no particles, but the fields are still there, present, real. This is the quantum vacuum, and it's not empty. It's a physical state, a configuration of fields. It has properties, it has energy, it has structure. Let me explain this in more detail. Because the quantum vacuum is central to understanding why nothing doesn't exist, in quantum mechanics, the vacuum is defined as the lowest energy state of the quantum fields, the ground state. But this ground state is not zero energy. It's not nothing. It has a finite positive energy. This is called zero-point energy or vacuum energy. Why does the vacuum have energy? Because of the uncertainty principle. In quantum mechanics, you can't know both the value of a field and its rate of change with perfect precision. There's always uncertainty, always fluctuation. Even in the lowest energy state, even in the vacuum, the fields are not perfectly still. They're fluctuating, oscillating, jittering at the quantum level. And this fluctuation has energy. This is zero-point energy. You can't remove this energy. You can't make the fluctuations go away. They're a fundamental feature of quantum mechanics. They arise from the uncertainty principle. And the uncertainty principle is not a limitation of our knowledge. It's a fundamental property of nature, a law built into the structure of reality. So the vacuum is not nothing. It's a state with energy, with fluctuations, with activity. It's the lowest energy state, but it's not zero energy. It's not the absence of everything. It's a something. And these fluctuations have real effects, measurable effects. The Casimir effect is one example. When you place two metal plates very close together in a vacuum, the vacuum fluctuations between the plates are restricted. Only certain wavelengths fit. Outside the plates, all wavelengths are allowed. This creates an imbalance, a pressure, a force pushing the plates together, and this force has been measured, confirmed experimentally. It's real. It's caused by the structure of the vacuum, by the fact that empty space is not empty. Another example is the Lamb shift, a tiny shift in the energy levels of atoms caused by the interaction between the electron and the vacuum fluctuations of the electromagnetic field. This has also been measured, confirmed. It's real. It's evidence that the vacuum is not nothing, that it has structure, that it's a physical thing. So physics tells us that even empty space, even the vacuum, is not truly empty. It's filled with fields, with fluctuations, with energy. And this means that nothing, in the intuitive sense, does not exist, cannot exist, at least not within the framework of quantum field theory. Now let me address the laws of physics, because the existence of laws is another aspect of why nothing might not be possible. The universe follows rules, regularities, patterns. We call these the laws of physics. And these laws are remarkably consistent. They're the same everywhere, at all times, in all places. As far as we can tell, the law of conservation of energy. Energy is neither created nor destroyed. The laws of motion. Objects move according to forces, the laws of electromagnetism. Charges attract and repel, the laws of quantum mechanics. Particles behave probabilistically. The laws of general relativity. Space-time curves in response to matter and energy. These laws are not arbitrary, they're not random, they're precise, mathematical, elegant, and they govern everything, every process, every interaction, every phenomenon. But where do these laws come from? Why these laws and not others? Why any laws at all? If there were truly nothing, there would be no laws, no regularities, no patterns, no structure. But if there are laws, then there's something. Laws are not nothing. They're constraints, structures, patterns. They're a form of existence, a form of being, abstract perhaps, but real. So the existence of laws is part of the existence of the universe, and asking why the universe exists is also asking why the laws exist, why there are regularities, why there are patterns, why there's structure. Some physicists and philosophers have argued that the laws of physics are necessary, that they couldn't be otherwise, that they arise from pure logic, from mathematics, from the structure of consistency itself. If this is true, then the laws are not contingent. They're necessary. They have to be this way. And if the laws are necessary, then perhaps the universe is necessary. Perhaps existence is necessary. But this is speculative. We don't know if the laws are necessary. We don't know if they could be different. We don't know if other universes with different laws exist. These are open questions, deep questions, and physics doesn't have definitive answers. But the point is this: the existence of laws is part of the existence of the universe, and laws are not nothing, they're something. So even if we imagine a state with no matter, no energy, no particles, if there are still laws, there's still something, not nothing. Let me now talk about the question of possibility versus necessity, because this is another way to approach the question of why the universe exists. There are two kinds of existence: contingent existence and necessary existence. Something is contingent if it could have been otherwise. if it depends on something else, if it's not required. Something is necessary if it couldn't be otherwise, if it must be, if it's required by logic or by the nature of reality. Most things we encounter are contingent. This chair could have been a different color. This house could have been built elsewhere. I could have been born at a different time. These are all contingent facts. They could have been otherwise, but some things might be necessary. Mathematical truths, for example, 2 plus 2 equals 4. This is not contingent. It couldn't be otherwise. It's necessary. It's true by definition, by the structure of mathematics itself. So the question is the universe contingent or necessary? Could it have been otherwise? Or must it be this way? If the universe is contingent, then its existence is a puzzle. Why does it exist? What caused it? What explains it? If it could have been otherwise, why is it this way? But if the universe is necessary, then the question changes. If the universe must exist, if existence is required by the nature of reality, then asking why it exists is like asking why 2 plus 2 equals 4. It's a question based on a misunderstanding. The universe exists because it must, because non-existence is not possible, because the laws of reality require existence. Now, is the universe necessary? We don't know. This is one of the deepest questions in metaphysics and physics, and we don't have a definitive answer, but there are hints, clues, suggestions. The stability of the universe is one clue. The universe has existed for billions of years. It's stable, consistent, predictable. It follows laws. It doesn't randomly collapse into nothingness. It doesn't spontaneously cease to exist. This suggests that existence is not fragile, not contingent on some external support, but perhaps inherent, built into the structure of reality. The consistency of the laws is another clue. The laws of physics are the same everywhere at all times. This suggests that they're not arbitrary, not contingent, but necessary, or at least deeply ingrained in the fabric of reality. The fact that the quantum vacuum has energy is another clue. Even empty space is not zero energy, not nothing, but something. This suggests that nothingness, in the absolute sense, is not a state that the universe can occupy. That existence is the default, not non-existence. These are hints, not proofs, but they suggest that the universe might not be contingent, that existence might be necessary, or at least that nothingness might not be possible. And if nothingness is not possible, then asking why there's something rather than nothing is asking the wrong question. The question should be, why is nothingness impossible? And what does that tell us about the nature of reality? Now let me talk about the stability of the universe, because this is another aspect of why the universe exists. The universe is not just a fleeting fluctuation. It's not a temporary blip that appeared and will disappear. It's stable, persistent. It's been around for about 13.8 billion years, and it shows no signs of collapsing into nothingness. Why is this? Why doesn't the universe just cease to exist? Why doesn't it collapse? Why doesn't it vanish? The answer is that the universe is in a stable state, or at least in a metastable state. Stable means the system is in a minimum of energy. Metastable means the system is in a local minimum. Not the absolute lowest energy state, but a state that's stable against small perturbations. Think of a ball in a valley. If the ball is at the bottom of the valley, it's stable. If you push it slightly, it rolls back to the bottom. It doesn't spontaneously roll up the hill. This is stability. The universe might be like that. It's in a state of minimum energy, or at least a state that's stable against small fluctuations. And because it's stable, it persists. It doesn't collapse. It doesn't vanish. But why is the universe in a stable state? Why this particular state? Why not some other state? Or why any state at all? This is where the laws of physics come in. The laws determine what states are stable, what configurations have minimum energy, what structures persist, and the laws themselves might be necessary, or at least deeply ingrained. So the stability of the universe is not arbitrary. It's a consequence of the laws, and the laws are part of the structure of reality, and this structure is not nothing, it's something. This brings us back to the question of why there's something rather than nothing, and the answer that's emerging is this. Nothingness might not be a stable state. It might not be a possible state. The laws of physics, the structure of reality, might require existence, might make nothingness impossible. If this is true, then the universe doesn't exist because of some external cause, some creator, some trigger. The universe exists because existence is the only possibility, because nothingness is not allowed, because the laws of reality require something rather than nothing. Let me now address the limits of physical explanation, because I want to be honest about what physics can and cannot tell us. Physics is extraordinarily successful at explaining how the universe works, how particles interact, how forces operate, how energy flows, how structures form, how the universe evolves. These are questions of mechanism, questions of process, questions of how. But physics struggles with questions of why. Why these laws? Why this universe? Why existence at all? These are questions of purpose, questions of meaning, questions of ultimate explanation. And physics might not be able to answer these questions. Not because physics is incomplete, but because the questions might not have answers within the framework of physics. They might be outside the domain of science. They might be philosophical questions, or metaphysical questions, or even meaningless questions. Consider the question, why do the laws of physics exist? Physics can't answer this, because physics uses the laws to explain phenomena. The laws are the starting point, the foundation. You can't use the laws to explain the laws themselves. That's circular. You could ask, where do the laws come from? And some physicists have speculated that the laws arise from deeper principles, from symmetries, from consistency requirements, from mathematical necessity. But this just pushes the question back. Why these symmetries? Why these consistency requirements? Why mathematics itself? At some point, you reach a stopping point, a place where explanation ends, where you have to say, this is just how it is. This is the foundation, and there's nothing deeper to appeal to. This is frustrating because we want ultimate explanations. We want to know why existence itself happens, why there's a universe, why there are laws, why anything at all. But maybe there is no why. Maybe existence is brute fact. Maybe the universe just is. Maybe the laws just are. Maybe there's no deeper explanation, no ultimate cause, no final answer. This is intellectually unsatisfying. But it might be the truth. Physics can tell us how the universe works, but it might not be able to tell us why the universe exists. That question might be beyond the reach of science. Now, let me shift perspective, because I think the question itself might be flawed, and understanding this is important. The question, why is there something rather than nothing, assumes that nothingness is a coherent concept, that it's a possible state, that it's simpler or more natural than existence. But what if this assumption is wrong? What if nothingness is not a coherent concept? What if it's not possible? What if existence is the only option? Then the question doesn't make sense. It's like asking why circles are round. Or why bachelors are unmarried? The answer is, by definition, by the nature of the concepts involved. Let me explain. When we talk about nothing, we're trying to imagine the absence of everything. No space, no time, no matter, no energy, no laws, no structure, absolute absence. But can we actually imagine this? Can we conceive of it? I don't think so. Every time we try to imagine nothing, we imagine something. We imagine empty space, or darkness, or a void. But these are all somethings. Space is something. Darkness is the absence of light, but it's still a state. A void is a region. All of these are structures, configurations, somethings, not nothing. True nothingness would be the absence of space itself, the absence of time, the absence of any structure, any concept, any possibility. But this is not something we can conceive, because conception itself requires structure. Thought requires time. Imagination requires space. We can't think about the absence of the conditions for thought. So maybe nothingness is not a coherent concept. Maybe it's an illusion, a linguistic construct, a word that doesn't refer to anything real or possible. And if nothingness is not possible, then the question, why is there something rather than nothing, is based on a false premise. It's asking why the universe is not in a state that's not possible. And that's not a meaningful question. This doesn't answer why the universe exists, but it reframes the question. Instead of asking why there's something rather than nothing, we should ask, why is nothingness impossible? What is it about the structure of reality that makes existence necessary, or at least that makes nothingness incoherent? And this is a question physics might be able to address by studying the laws, by studying the quantum vacuum, by studying the stability of the universe. By understanding the structure of reality at the deepest level, let me now talk about quantum fluctuations and the origin of the universe, because this is often invoked in discussions of why the universe exists. In quantum mechanics, there's a famous idea called quantum fluctuations. These are temporary violations of energy conservation, allowed by the uncertainty principle. For very short times, energy can appear out of nowhere and then disappear. This is not a violation of conservation of energy on average, but locally, temporarily, energy can fluctuate. Some physicists have speculated that the universe itself might have originated as a quantum fluctuation, a temporary bubble of energy that somehow became permanent, that inflated. That became the universe we see today. This is a bold idea, and it's been explored in various forms. Quantum cosmology, vacuum fluctuation models, inflationary cosmology. These models suggest that the universe didn't need a creator. It didn't need an external cause. It could have emerged spontaneously from the quantum vacuum, from nothing. But here's the key point. This nothing is not absolute nothingness. It's the quantum vacuum. The state of quantum fields in their lowest energy configuration, and as I've explained, the quantum vacuum is not nothing. It's something. It has fields, it has energy, it has structure, it has laws. So even if the universe originated from a quantum fluctuation, it didn't come from absolute nothingness. It came from the quantum vacuum, from a pre-existing state with pre-existing laws. And that state is something, not nothing. This doesn't answer the question of why the quantum vacuum exists, why the laws exist, why there's structure at all. It just pushes the question back. But it does show that the universe doesn't require an external creator, that it could have originated naturally from the quantum vacuum, from the fluctuations allowed by quantum mechanics, And this is significant because it shows that existence doesn't require supernatural intervention. It doesn't require a miracle. It can emerge naturally from the laws of physics, from the structure of the quantum vacuum, from the possibilities inherent in quantum mechanics. But it doesn't answer the deeper question, why the quantum vacuum? Why quantum mechanics? Why any laws at all? These questions remain, and they might not have answers, at least not within physics. Now let me address the multiverse, because this is another idea that's relevant to the question of why the universe exists. The multiverse is the idea that our universe is not unique, that there are many universes, maybe infinitely many, each with different properties, different laws, different constants, different histories. This idea arises from several sources: eternal inflation, quantum mechanics and the many worlds interpretation, string theory, and the landscape of possible vacua. All of these suggest that our universe is just one among many. If the multiverse is real, then the question of why the universe exists becomes a question of why the multiverse exists. And the question of why our particular universe has the properties it has becomes a question of selection, of probability, of the anthropic principle. The anthropic principle says that we observe the universe we observe because we exist. And we can only exist in a universe that's compatible with our existence. So the fact that our universe has the right properties for life, for complexity, for observers, is not surprising. We couldn't be in a universe that doesn't have these properties. We wouldn't exist to observe it. This is a form of selection bias. We're in a universe that allows us to exist, not because it was designed for us, but because we're biased toward observing universes that allow us to exist. If the multiverse is real, then existence is not a puzzle. The multiverse is vast. It contains all possible universes, or at least a vast number of them. Some have stars, some have galaxies, some have planets, some have life, some have observers. We're in one of the ones that has observers. Not because it's special, but because observers can only exist in universes that allow observers. But this still doesn't answer the question of why the multiverse exists, why there are laws that allow multiple universes, why there's structure, why there's anything at all. The multiverse just enlarges the scope of existence. It doesn't explain existence itself. So the multiverse is an interesting idea, but it doesn't solve the fundamental question. It just reframes it. Instead of asking why our universe exists, we ask why the multiverse exists. And we're back to the same mystery. Let me now return to the question of laws, because I think this is the most important aspect of why the universe exists. The laws of physics are not arbitrary. They're not random. They have structure, patterns, symmetries. They're elegant, beautiful, mathematically consistent. Why is this? Why are the laws structured? Why are they consistent? Why do they have symmetries? Some physicists believe that the laws are not fundamental, that they arise from deeper principles, from mathematics, from logic, from consistency itself, that the laws are necessary, that they couldn't be otherwise, that they're the only way reality can be. If this is true, then the laws are not contingent, they're not chosen, they're not created, they're necessary. They're inherent in the structure of reality. And if the laws are necessary, then perhaps existence is necessary. Perhaps the universe exists because the laws require it, because the laws make existence inevitable. This is speculative. We don't know if the laws are necessary. We don't know if they arise from deeper principles. We don't know if there are other possible laws. These are open questions. And physics doesn't have answers. But the idea is appealing because it suggests that existence is not arbitrary, not accidental, not contingent on some external creator, but necessary, inherent, inevitable, a consequence of the structure of reality itself. And this brings us to a different way of thinking about the question. Instead of asking why the universe exists, we ask, what is the structure of reality that makes existence necessary? What are the principles that require the laws, that require the quantum vacuum, that require something rather than nothing? And this is a question that physics might be able to address by studying the laws, by looking for deeper principles, by searching for a theory of everything, a unified theory that explains all the laws, all the forces, all the particles, all the phenomena. Such a theory might reveal why the laws are the way they are, why existence is necessary, why nothingness is impossible. And this would be a profound answer, not a complete answer, but a deep one. Grounded in physics, grounded in mathematics, grounded in the structure of reality. Now let me address the role of time, because time is crucial to understanding existence. When we ask why the universe exists, we're implicitly asking about a moment, a beginning, a point in time when the universe came into existence. We imagine a before and an after. Before the universe existed, there was nothing. After, there was something. But this assumes that time is fundamental, that time exists independently of the universe, that there can be a before and an after even if there's no universe. But in physics, time is not independent of the universe. In general relativity, time is part of space-time. Space and time are unified. They're aspects of a single structure, and space-time is dynamic. It curves, it expands, it's shaped by matter and energy, and space-time might have a beginning. The Big Bang is often described as the beginning of time, the moment when the universe and time itself began. Before the Big Bang, there was no time, no before, no after, no duration. If time itself began with the Big Bang, then asking what came before the Big Bang is meaningless. There is no before. Before implies time, and time didn't exist before the Big Bang. So the question doesn't make sense. This is one way to think about the origin of the universe. Time is part of the universe. The universe doesn't exist in time. Time exists in the universe. And if the universe began, time began with it. And there's no before to explain, no prior state, no external cause. But this raises another question. How can the universe begin if there's no time for the beginning to happen in? How can something come into existence if there's no prior moment? This is where quantum mechanics comes in. In quantum mechanics, causality is not strict. Events can happen without prior causes. Quantum fluctuations can occur spontaneously. The quantum vacuum can fluctuate, and these fluctuations can give rise to universes. So the universe might not need a prior cause, it might not need a before, it could emerge spontaneously from the quantum vacuum, from the fluctuations allowed by quantum mechanics. And time would begin with this emergence. There would be no before, just the beginning. This is speculative, and it's not fully worked out, but it's a possibility. A way to think about the origin of the universe without requiring an external cause, without requiring a before. Just the laws of quantum mechanics, the quantum vacuum, and the spontaneous emergence of space-time. Let me now talk about what it means to exist, because this is central to the question. When we say the universe exists, what do we mean? We mean that it's real, that it has properties, that it occupies space, that it persists through time, that it can be observed, measured, interacted with. But existence is not a property in the usual sense. You can't point to existence. You can't measure it. You can't detect it with an instrument. Existence is more fundamental. It's the precondition for having properties, for occupying space, for persisting through time. Some philosophers have argued that existence is not a property at all. It's a quantifier, a statement about whether something is in the domain of reality. To say the universe exists is to say that the universe is in the set of things that are real, that it's not fictional, not imaginary, not hypothetical, but actual. But this doesn't explain why the universe is in the set of real things, why it's actual rather than merely possible, why it's not fictional. And this brings us back to the question, why is the universe actual? Why is it real? Why does it exist in the fullest sense? And the answer might be that existence is not contingent, that it's not a property that can be present or absent, that reality is all there is, that the universe exists because reality exists. And reality is not contingent, it's necessary, it's the foundation, the base level, the ultimate fact. This is a form of metaphysical realism, the view that the reality is independent of our minds, independent of our observations, that it exists objectively, necessarily, and that the universe is part of this reality, not contingent on anything else, but fundamental, irreducible, just there. This doesn't answer why reality exists, but it reframes the question. Instead of asking why the universe exists, we ask, what is reality, and why is reality necessary? And these might be questions without answers, questions that reach the limits of explanation, questions that can only be met with, this is how it is, this is the foundation, there's nothing deeper. Let me now bring all of this together, because I want to make sure the key ideas are clear. The question of why the universe exists is one of the deepest questions we can ask, but it's also one of the most difficult. And physics, for all its success, might not be able to answer it completely. But physics does give us insights. It tells us that empty space is not truly empty, that the quantum vacuum is a physical state, with fields, with energy, with fluctuations. And this means that nothingness, in the absolute sense, might not be possible, at least not within the framework of quantum field theory. Physics tells us that the universe follows laws, regularities, patterns, and these laws are not arbitrary. They're structured, elegant, consistent, and the existence of laws is a form of existence. Laws are not nothing, they're something, and their existence is part of the existence of the universe. Physics suggests that the universe is stable, persistent, not a temporary fluctuation, not a fragile accident, but a state that persists, that doesn't collapse into nothingness. And this stability might be a consequence of the laws of the structure of reality, of the fact that existence is a stable state, or the only possible state. Physics raises the possibility that existence is necessary, not contingent, that the laws make existence inevitable, that nothingness is not a coherent concept, not a possible state. And if nothingness is impossible, then asking why there's something rather than nothing is asking the wrong question. But physics also has limits. It can tell us how the universe works, but it might not be able to tell us why the universe exists. That question might be beyond the reach of science. It might be a philosophical question, a metaphysical question, or even a meaningless question. And that's okay. Science doesn't have to answer every question. It doesn't have to provide ultimate explanations. It can tell us what the universe is like, how it behaves, what the laws are. And that's already extraordinary, profound, valuable. The question of why the universe exists might not have an answer, or it might have an answer that's beyond physics, beyond science, beyond human understanding, and that's part of the mystery, part of the beauty, part of the wonder of existence itself. I want to end with a reflection, because I think this question, even if it doesn't have a definitive answer, is worth thinking about. For most of human history, we've asked why the universe exists, and we've given many answers. Gods, creators, first causes, necessary beings, eternal laws, self-creation, brute facts. But in the last century, our understanding has changed. We've learned about quantum mechanics, about the quantum vacuum, about fields and fluctuations and zero-point energy. We've learned about space-time, about the Big Bang, about the laws of physics and their structure. And these discoveries have changed how we think about existence. They've shown us that nothingness is not simple, that empty space is not empty, that the vacuum is not void, that the laws are not arbitrary, that existence is not fragile. And they've suggested, though not proven, that existence might be necessary, that nothingness might be impossible, that the universe exists because it must, because the laws require it, because reality is structured in a way that makes existence inevitable. This is not a complete answer. It doesn't explain why the laws are the way they are. It doesn't explain why reality has the structure it has. It doesn't answer every why, but it's a start. It's a framework. It's a way of thinking about existence that's grounded in physics, in observation, in the structure of reality as we understand it. And maybe that's enough. Maybe the universe doesn't need a reason. Maybe existence doesn't need an explanation. Maybe the universe simply is. Maybe existence is the natural state, the default, the only possibility. And maybe the question, why is there something rather than nothing, is based on a misunderstanding, on the assumption that nothingness is possible, on the assumption that existence needs justification. But if nothingness is impossible, if existence is necessary, then there's no puzzle, no mystery, just reality, just existence, just the universe, here, now, always. The universe may not need a reason. It may simply be what happens when nothing is impossible. And that, I think, is a profound realization. Not the answer we expected, not the answer we wanted, but perhaps the answer that physics is pointing us toward. The universe exists because it must, because nothingness is not an option, because existence is woven into the fabric of reality, because the laws, the fields, the quantum vacuum, the structure of space-time, all of it requires something rather than nothing. And we are part of that something, made of the same fields, subject to the same laws, temporary, fleeting, but real, existing, part of the universe, part of existence itself. And that's not nothing, that's everything. Thank you.